Increasingly, policymakers are turning to mathematical models to answer questions about the COVID-19 pandemic. But these models aren't great for providing the numbers that they seek, nor for making predictions in general. These models are really designed to give better precision to our ideas. They're not crystal balls, they're a pen sieve, a means by which we pull ideas out of our head, swirl them around to get a better idea of the ramifications of our assumptions. There's been a progression of models over the course of the epidemic. The first models were like rockets sent up at an approaching target. No one cared how high they went or where they landed. They were answering questions like, how many in the hospital next week? How many in the ICU? As the epidemics progress, the questions have changed. Now we're asking about social distancing. And we tend to shift towards network versions of these models so that we can better model how we're interacting with one another. And these models generally predict a smaller epidemic, but one in which those with greater connectivity are at higher risk of becoming infected. We're also getting a ton of data in, and we're working to fit these models to that data, but we're doing so on the fly. Most of our statistical methods that we rely on usually assume independence among observations. And that's a non-starter for an infectious process like a disease. But we really need to get back to what these models are best at, and that's serving as a guide for future investigations. We need to start asking the questions that are going to be so critical in the coming months. How do we design a vaccine trial? How do we reopen schools? And how do we shut them again if the virus reemerges?